Good morning. This is Sonia Mathur, Associate Professor in Chemistry, Government JDB Girls College, Kota. In my today's lecture, I will be discussing the topic for M.Sc third semester students, paper 3.1, chemistry 631 code, and my topic is chromatography, unit 2nd. In this chromatography, we will be discussing thin layer chromatography, which is abbreviated as TLC. In this unit of thin layer chromatography, we have to discuss principle, advantage over paper chromatography, types, preparation of thin layer, choice of sorbent and solvent, development, detection, and lastly, the applications. Now, there are two basic types of chromatography. Gas first and second is liquid. Now, liquid includes TLC and high performance liquid chromatography. This type of chromatography was first of all discovered by scientist Michael Spett. So Michael is credited as being the father of liquid chromatography. Michael developed his ideas in the early 1900s. Now a brief introduction. TLC is a form of liquid chromatography consisting of first a mobile phase, that is the developing solvent, and a stationary phase, which is usually a plate or strip coated with a form of silica gel. Analysis is performed on a flat surface under atmospheric pressure and room temperature. The two most common classes of TLC are normal phase and second is reverse phase. Normal phase is the terminology used when the stationary phase is polar. For example, silica gel, and the mobile phase is an organic solvent or a mixture of organic solvents which is less polar than the stationary phase. Reversed phase is the terminology used when the stationary phase is a silica bonded with an organic substrate such as a long chain aliphatic acid like C18, and the mobile phase is a mixture of water and organic solvent which is more polar than the stationary phase. Thin layer chromatography is used to separate mixtures of substance into their components, similar to paper chromatography, except that a thin layer of some inert material, that is aluminium oxide, magnesium oxide, silica oxide, is used instead of paper. A layer of any of these oxides is made from a slurry of power in a suitable inert solvent. Slurry is spread over a flat surface like glass, metal or rigid plastic and dried. Now the principle. The principle of thin layer chromatography we'll be discussing now. Adsorption. The component with more affinity towards the stationary phase travels slower. The component with lesser affinity towards the stationary phase travels faster. Advantages of TLC. The advantages of TLC. This method involves simple material and cost of the equipment is low. It is a rapid technique and not time consuming like column chromatography. It also involves separation of micrograms of the substance, which can be easily achieved. Any type of compound can be analyzed. Corrosive spray reagents can be used without damaging the plate and need less solvent. Now the steps in TLC analysis. The following are the important components of a typical TLC system. First is the apparatus, which is the developing chamber. Second, the stationary phase layer and mobile phase. Then is application of the sample. Then the development of plate. And finally, detection of analyte. Now the practical requirements of stationary phase are silica gel H, which comprises of silica gel without binder. Then it can be silica gel G, which is silica gel plus calcium sulfate. Silica GF, that is silica gel plus binder plus fluorescent indicator. Then it can be alumina, cellulose powder, and so on. The second is glass plate. The glass plate has specific dimensions, which is 20 cm by 20 cm. It can be 20 cm by 10 cm or 20 cm by 5 cm. Then microscopic slides can also be used. Plates should be of good quality and withstand high temperatures. Then preparation and activation of TLC plates involve pouring, which is the simplest method, dipping used for small plates, spraying, difficult to get uniform layers, and spreading, which is the best technique. This is the apparatus setup. Here we see that in the beaker is a thin layer chromatography plate. This is a spot where we apply the mixture. In the beaker we fill the solvent, and this is covered by the watch glass. Now in this we see how the various components of the mixture, they travel by the different distances, and this is the distance traveled by the solvent. So this is the height reached by the solvent, and these are the three different components in the mixture. Here we are drying the plate by the UV light. So this is just a sketch or a rough outline of the whole setup that is done in thin layer chromatography. Now how is the activation of plates is done? First is after spreading, it is air dried for 5 to 10 minutes. Then it is activated by heating at about 100 degrees centigrade for 30 minutes. Then the plates may be capped in desiccator. The next step involves application of the sample, which is using capillary tube or micropipette, and then spotting area should be immersed in the mobile phase. The last is the development tank. Better to develop in glass beakers, jars to avoid more wastage of solvents. When standard method is used, use twin trough tanks. Do chamber saturation to avoid edge effect. Now we discuss the mobile phase. Mobile phase used depends upon various factors like nature of the substance, nature of the stationary phase, then the mode of chromatography or separation to be achieved analytical and preparative. For example, the mobile phase examples include pyridine, petroleum ether, carbon tetrachloride, acetone, water, glycerol, ethanol, benzene, etc. The development technique involves one-dimensional development, two-dimensional development, horizontal development, and multiple development. The detection of visualizing agents involve non-specific methods in which iodine chamber method, sulfuric acid spray reagent, ultraviolet chamber for fluorescent compounds, and using fluorescent stationary phase. So in the specific methods, we have spray reagents or detecting agents or visualizing agents, same as the paper chromatography. Now the qualitative analysis, the RF value. The ratio of distance travelled by the sample and the distance travelled by the standard is the RF value. The quantitative analysis involves direct and indirect method. Now the applications of TLC. First, to check the purity of a sample. Second, examination of a reaction. Third, identification of compounds. Fourth, biochemical analysis can be done. Then we have TLC find great use in pharmaceutical industry. Then separation of multi-component pharmaceutical formulations. And last and the final is in food and cosmetic industry. So this was a outline of thin layer chromatography technique. This is just a complete outline involving the principle, instrumentation, method, and the applications of TLC. You can view this YouTube by subscribing the YouTube channel of Government JDB Girls College, which is CCE RAJJ DBC Kota. Thank you.